Hello guys, welcome back. Today I'd like to talk about chapter 5 on systematic sampling. Systematic sampling is relatively, as compared to simple random sampling, stratified random sampling, it is a rather simple sampling scheme that we can randomly choose some of the sample from the population in a systematic manner. That's why it's called systematic sampling. So the systematic sampling is very easy to operate. So as long as we know the total population numbers and we know that we want to choose a certain numbers from the population to form our samples, then we would choose a 1 in k systematic sample. So let's say if I have a population of 100, if I have 100 students and I decided to collect 20 samples, then I would have 100 divided by 20 of my samples size, so k would become 5. So in this case, I'm going to choose every fifth element from the populations. Okay, how does it work? Let's say, back to our example, we want to order the population units from 1 to 100 in a way that is defined. So let's say we give every student a number 1 to 100. Then we draw a 1 in 5 systematic sample, and at the end of the day, we can draw 20 students, right? So we select a unit at random at the random start from the 5th unit. So from 1 to 5, we randomly choose a random start. Let's say number 3, okay? So number 3 is my first selected student, the third one. And then every fifth item, so the third one plus 5 would be the 8th student, and then the 13th student, and then the 18th, 23rd, 28th, etc., until we come up to the 93rd, 98th students from the 100 students. So you can see that we can eventually collect 20 students from the hundreds list of the population in a systematic way. So each of the selected sample, they would be equally width, distance to each other. And then as an interviewee or as a researcher, we find it very easy to perform or to collect a sample from the population. The systematic sample provides a very useful alternative to simple random sampling, because in simple random sampling, we need to look for a random number. But one cautions with the simple random sampling is that even though we randomly choose some of the sample from the population, the random number could be clustered in a certain area. So even though our intention would be randomly chosen or choose from random number, but systematic sampling is really spread across the entire population if we order the population in a proper way. So the advantage of using systematic sampling is that it simplifies the selection process and it can be executed easily, which would be a very good news for the researchers. It's just less subject to the selection errors because the selection process is well defined due to the interviewers or the field workers, and even though the sampling frame is not required. So what we are trying to say is that in stratified random sampling, or sometimes in simple random sampling, we need to obtain the entire sampling frame so we can choose the sample from that, right? But for systematic sampling, one key thing is that we just need to decide every kth item from the population to be chosen to form our sample. Let's say a very good example, like if I ask a researcher to get an opinion from someone who shops at a supermarket, then due to bias or some of the interviewee bias, his own judgment, he might tend to choose some of the interviewer who looks the interviewees who looks a bit more friendly to be interviewed, right? If that's the case, that involves some of the bias in the selection of the sample. But if I tell the interviewer to go into to go at the entrance or the exits of the supermarket and ask him to ask every 10th shopper who came out from the supermarket, no matter who she is or who is, or is it going to be an elderly or a student, it doesn't matter. Every 10th shopper or every 10th customers who came out from the supermarket, and then to interview him or her. So this would be a systematic way, even though we don't have the capital N, the total population, to be calculated. As long as the interviewer collect 20 datas, then we can have a systematic way of choosing my sample. Secondly, it provides greater information per unit cost than the simple random sampling, because if this is easier to operate, apparently this is cost-wise that would have a much better information or being more effective. Systematic sampling is used when there is naturally defined order of the arrangement in the elements of the population. A systematic sample generally spread more uniformly over the entire population. So like I said, even though we use a simple random sampling, even though a random number was generated, we might cluster in a certain area of the samples to be selected. But systematic sampling, that's like our first example, like we can choose every 5th student across the entire population. So all of the samples that being chosen would be naturally defined and would be spread more uniformly across the entire population. Okay, and then how well we can form this kind of sample, that really depends on the orders of the populations that we order them. Okay, we come back to this. The accuracy of the estimate from the systematic sampling really depends on the order of the sampling units. How we put the population, how we order them in a way that we can randomly choose every systematic sample from the population. That could, in a way, at some point, could increase the accuracies of our estimate. Okay, so let's look at some of the systematic sampling example. For example, in an industrial quality control and inspection plan for the manufactured items moving along the assembly line. So imagine that at Nike shops, or not the Nike manufacturing company. So they have the conveyor belt having each pairs of the Nike running shoes being manufactured coming out. So the inspector having a quality control, if they randomly choose the first 10th, that would be quite this is not actually randomly chosen, right? So a better way to choose the shoes to be checked would be every 20th items or every 20th of the pair of shoes to be chosen and have the quality check. And then we can make sure that the entire population or entire products to be produced could have evenly spread across the population. Secondly, in university, like 7,500 students, we want to take a sample of 500 students. So let's say if that's the case, 7,500 divided by 500. So we are going to break it into the segment of 15 each. So if that's the case, we are going to choose a sample of 1 in 15th systematic sample. Okay, so we can choose, for example, we have a random start from the 1st to the 15th. Let's say the 10th students going to be chosen being the first element, and then every 15th, so the 10th next would be the 25th, and then it's going to be the 40th, etc. And then we choose 500 of those students in a systematic way. Or thirdly, a library has 25 inches of the index cards in the book collection. So every time I talk about this example, I find it quite interesting, because nowadays students go to the library, they look for books on internet or the computer, they don't really know what the index card would be in the library. That would be the very old days. So imagine in the old days in the library, every book would have an index card to be written down all of the book, the description, the location of the book being stored, etc. And then they put each of the index card in the book collection drawers. Okay, so if that's the case, we imagine we have 25 inches of the index card. So we have many cards, many books, index cards referring of each of the books. So we want to randomly select 100 books at random. So let's say if that's the case, we can divide that 2500 inches by 100. So every 25 inches will become the intervals. Okay, so let's say if we randomly choose from 1st to 25th, we have a random sort. So let's say first card was chosen, then the 26th card, and then 52nd card, etc. 51st, and then the next would be chosen in a systematic way out of the box. Okay. All right, the next section, I would like to arrange the population units in a two-way tables. Okay, so back to the example earlier that we said that we have 100 students and then we want to collect 20 samples. So in this case, we are going to choose a 1 in 5 systematic sample, right? How are we going to do that? First of all, we arrange our students, give them a number. So the first student, second, the third, fourth, fifth, and then we move on to the next row, and then the 6th, 7th, 8th, 9th, 10th, etc. And then the 99th and 100th students. So in a systematic way, we can have a random start from the 1st to the 5th student. Let's say we choose the 2nd student to be our random start. Then the 7th, the 12th, 17th, etc. would be our sample selected. So in this case, systematic sampling is equivalent to selecting one row of units at random. And if that's the case, we're choosing this as our sample, and we can calculate the mean of our sample. So Y2 bar is very much like choosing this sample from the populations. Y2 bar is the unbiased estimator for the population mean. But in systematic sampling, we can think of the way of choosing the sample is a cluster. Or we can say that systematic sampling is indeed a special case of a cluster sampling when the cluster are of equal size and also one particular cluster would be chosen. So if this is the case, the second row would be chosen, and this becomes our systematic sample, and Y2 bar would be our sample mean. Or alternatively, we can say that a sample is chosen with the probability of 1 out of k. Yes, because we are putting our student into 5 of them. So a random start could either be the 2nd student, or the 3rd student, or the 5th students, etc. So every sample would have 1 out of 5, 1/5 of the chance of being chosen. This systematic sampling, actually we ensamples the simple random sampler in that every unit would have a equally likely probability of being chosen. So as a result, systematic sampling is sometimes as the substitute of the simple random sampling for the last stage of the multi-stage sampling design. But however, there are only k possible samples. So if we look at this example, that we have 100 students, if we put it this way, we only have 5 possible samples to be chosen if we have a 1 in 5 systematic sample, instead of n choose n possible sample units that we are choosing. Okay. Lastly, comparing the systematic sampling with the stratified random sampling. Stratified random sampling, we said that within stratum, we want them to be homogeneous. But systematic sampling, we want them to be heterogeneous. Okay, so this is why systematic sampling is one kind of the cluster sampling.